this lesson, we're going to talk about inversions of triads and figured bass. And it's a slightly tricky concept because of this dual status of the triad. So on the one hand, we think of the triad root, third, fifth, actual pitches, an actual third, an actual fifth, written in this way. But we understand that here's a G, here's an E, here's a C. This set of pitches can also be understood to instantiate the C major triad, so that in a sense, the triad is a pitch class structure, even though when we talk conceptually about root, third, and fifth, we're referring to this closely spaced collection of actual pitches. Now, when we talk about inversions, let's talk about it first with respect to this kind of conceptual laboratory, and then we'll bring it over to a more general actual usage. So what happens when we invert triads is very similar to what happens when we invert an interval. We take what's on the bottom and we pop it up an octave. Okay? Now if I do this, turns into, it's the same collection of pitch classes, but the note on the bottom is different. And I really want to emphasize that. What we care about here is the note on the bottom. So when the note on the bottom is the root, we're going to call it root position. When the note on the bottom is the third, we're going to call it first inversion. And of course, there's one other possibility. I pop the third up as well. So I had been here. In this case, we're going to talk about second inversion. Now here's where things get a little bit confusing. As we move from this picture of this laboratory with closely spaced actual intervals, this is what used to be a fifth turns into a perfect fourth. It's not a compound perfect fourth, it's a simple perfect fourth. Oops. I'll have to fix that on the website because you won't have gotten this far yet. But I should have mentioned earlier, if an interval is not a compound interval, if it's within an octave, it's called a simple interval. Sorry about that. I'll have to make a little addition there. So we've got a simple fourth, not a compound fourth, these closely spaced pitch structures. Now, as we generalize this out, we still care about the lowest sounding note. So because we care about the actual register of the lower sounding note, or at least we care about which part of the triad is the lowest sounding note, in that sense, it's a pitch structure and not a pitch class structure. Because if I look at this as pitch classes, then we've got C, E, and G in no particular order, and there's nothing there that tells me which note is in which register. Now, if I start to turn this into a pitch structure, then I'm going to call this G2, C4, and E5. And I'm actually not going to go quite that far, because I don't care what register the rest of these things are in, and I don't even care if we fill it out with a few more. I might add something like that. All I care about, I can have extra versions of the same parts of the triad. All I care about is which note is on the bottom, okay? The note that's on the bottom determines which inversion. If the fifth is in the bottom, therefore, this is second inversion, okay? I can put this an octave higher. Note that the highest note here is the third. Now let's make the highest note the root. I can do that. I can take away all the extra things so it's only 3 notes instead of 5. This is also, and equally, a second inversion triad. All I care about is what note is on the bottom. So the lowest sounding note Whatever member of the triad that is, that determines the inversion.